Hello everyone, in this video I'm going to model a sci-fi panel using random flow. This was requested through my socials and this will be mostly a beginner-friendly workflow relative to the random flow add-on. So let's begin by creating the base mesh, and in this instance it will just be a simple primitive plane. But before we start modeling the actual asset, I'm going to show you how topology affects the randomization. So the randomization algorithm doesn't just come up with the random patterns from thin air. It actually uses the topology of the source mesh being the active mesh being used for the randomization. It uses that topology to create the panel island or face group patterns. So for example, if we create this kind of topology, which is a mix of relaxed and more densely packed areas with faces. So with this kind of topology, the face group that will be generated in this area will be more relaxed and will be bigger compared to the area right here, which have more densely packed faces. There will be more, the face islands or first face groups generated here will be um, smaller and also more densely packed. And we're going to use random panels to demonstrate this effect. So we increase the resolution. Let's use the radial solver. You can see that in this area, more relaxed, the panel islands or face groups are much bigger, and in this area right here, the face groups or panel islands are much smaller and more densely packed because of the underlying topology. And also the faces or the length and width of the faces also affects the resulting randomized panel islands. So in this video, besides showing you how to create or start modeling with random flow, I'm also going to show you the layering method that can be used with random flow to create detailed models. So the layering method involves steps where, for example, in layer 1, we create big shapes, the primary shapes, and in the second step or layer, the secondary detail, we create another set of detail using the first randomized result, and then stack those data on top of that by using by increasing the resolution essentially. And then from the secondary shape or the second stage or the second layer, you can then choose to create the third layer or the tertiary shapes, and then so on. And in this particular video as well, we're going to use, or I'm going to show you the merged feature using the random panels. So the merge feature is where the randomized result will be merged to the source mesh instead of creating another object, which is a non-destructive result. Using the merge option will be a destructive result. So for most of the random operators, the process will be non-destructive, meaning that um, the resulting pattern or randomized mesh will be another set of object parented to the source mesh, unless of course you turn off the parent to source. But this is how the add-on behaves by default. It creates those details by creating another object, and it also only affects the face selection from the source mesh. And from that face selection, when you increase the subdivision, the faces from that face selection will resolution will be increased, thereby granting the algorithm or the randomization algorithm to have more faces to play with, thereby uh, creating the or adding more details in effect because of the increased number of faces. So, okay, for the layering method, for example, in the non-destructive method, we create, for example, this layer is the first layer, and then we just select another. We just use the random result from the first operation for the second layer. Like for example, this one, and there you go. Increase the resolution, and this is the second layer. But for the merge feature, it's quite different. It basically involves the same thing. You can still use the same method, but the process will be destructive, and the details will be stacked on top of the same object. Okay, or and not create separate objects in the same in different operations. Okay, so for the merge panel, of some of the operators, random operators and random flow also has this. For example, or the destructive nature of using the merge panel toggle. For example, plate insets is purely destructive, as well as quick displacement is also purely destructive. And also we have random axis extrude. You can choose it to be destructive, just like random panels by hitting this. Single object it means that the result will now be merged to the source mesh. You can see the outline of the source mesh here. If we press single object, you can see that the outline has evolved to include the result of the random axis extrude. Okay, so let's start with the Scifi panel and mirror this using Creative Flow's auto mirror. This operator is also available in random flow. Just in case you don't purchase Creative Flow but still need to use symmetrical modeling. This also has extract faces from Creative Flow, but they're quite different, being that this is more feature rich from Creative Flow, while the extract faces in Random Flow is much more limited, but is functional only to the point that it's useful to the Random Flow add-on. Okay. Auto mirror, pick the area of the mesh you want to mirror. Now that spot, we go into model mode. Now that spot is marked with the X right here, black X, and this striped line goes to where the origin point of the object is, or the source mesh, and then you can see the white 3D widget here. It means that the XYZ axis is not activated yet. If you activate, for example, X, then that axis will color up or light up. Then Y. So we only need to mirror this in the XY axis, and then you can press space or enter to activate. You can see that the area that we click is our real geometry, and the rest will be will be the virtual mesh generated by the mirror modifier. And now we can do symmetrical modeling. And if we use the random operators, by default, the random operators will inherit the mirror modifier from the source mesh, except for when you activate copy all modifiers. then all the modifiers from the um, source mesh will be copied as well. But turning this off, then the random operators will only copy the mirror modifier from the source mesh. Okay. So first off, since I've shown you that the topology, um, influences the randomization script or randomization algorithm, then we can actually take advantage of that and design the topology in order to affect the way the random patterns will be created. So for example, if you want more face groups or panel islands here, you can add more faces there. And in here, you want more relaxed pattern, then you can, of course, create bigger faces. So let's just see how this works. Okay. Random panels, and in the presets, we're going to use square tap merge. So the name kind of hints at what the properties will be used in the redo panel. So square tap merge means that the solver you will use will be square, and then the limit smooth will be tap, and the merge panel will be on. Okay, so this is just a start, kind of like the presets are kind of like a starter pack to let you learn more about the properties. And also, I finished the online documentation for random flow. You can find the link on the product page and read all about each of the operators there. So most of the operators properties listed here will have GIF images to show you how they work. Okay, so besides the informative text on top. Okay, so we're not gonna actually use the preset in its original form. We're going to modify some of the properties. For example, even offset, we're not dealing with really angular. The source mesh is not that angular, so it's just a simple plane. So we're going to turn this off and probably soften the effect of the depth. The depth is the height of the extrusion of the panel islands. And we also have distance to get rid of the symmetry line. Then we can play around with the subdivision and the panel seed to create the detail that we want. So I've increased the inner margin. We have the outer margin, which of course creates margin for the faces that are indented, embossed, and we have inner margin for faces that are debossed, or maybe it's in reverse. I don't know. Forgot how those two are different to each other. Okay, so what we're doing here, so again, we're going to try and deal with bigger faces in the first layer. So this could actually be good. But let's remember the number 19. Or you can copy it, Control C, then play around with the seed, and then what's the number that you can that I used earlier? You can just go back by pasting it in the same property by using Control V. Control C to copy, Control V to paste. Okay. And also for the information about the disappearing panel. Once the mouse cursor skips and goes over the border of the redo panel, it disappears. I'm gonna link this. I'm gonna post a link in the description of the video where you can uh, read all about how this works in Blender. So this is an Blender internal behavior, and this is not uh, limited to the add-on, or it's not designed for the add-on. This is Blender internal behavior, and you can see this. So, for example, if I move this object here and press F9, this is the same redo panel. And if I move the 3D cursor out of the boundaries of this redo panel, it disappears. Okay, so what I'm doing with random flow is just using a different method of the redo panel, which is show it pre operation um, pre confirmation of the command. So nothing's happening yet. So it's shown instead of the command is finished, then the redo panel is shown. So with random flow, the redo panel is shown first. But the link will explain it all, and it will also provide you with information about using the confirm. You could use the OK version of the redo panel right here to have it a bit more to have it static in this area here and not disappear all the time. Okay, so let's go back to the Sci-Fi panel. So we can use this as our first layer. Yes. Okay. So with the layering, with the non-destructive part, okay, select cursor to world origin, selection to cursor, if offset, it's not working. There we go. So with, for example, right here, I'm going to use random loop extrude for this example. So for this instance, you can select a whole island using the L hotkey. It works in vert selection mode number 1, and edge selection mode number 2, face selection mode number 2. With each mode, you just have to hover the mouse on that particular element. So number 1 is vertex selection. Hover the mouse cursor on the vertex, on any vertex, and press L. Then it will select all the connected vertex from that original vertex you've hovered on, the mouse cursor on, and then, yeah. The only way it's going to stop is for terminal edges or non-manifold edges, but with vertices on vertices on separate islands, they will not be selected. However, this works with this kind of topology, but if those elements are connected, for example, this face here, number 3 selection, so hover over a face and press L, it will select everything because they are all connected. But if that face has been encircled by edges that are marked, the whole seams are marked, then if you use number 3 selection, which is no, face selection, which is using hotkey 3, number 3 hotkey, and press L on any face, then the propagation of the face selection will stop on those edges. This only works on the face selection mode, not in vertex selection mode or edge selection mode. Once you go to face selection mode, this limit will start to work, or limiter will start to work. And this is true with random panels using the merge feature. The the pana island's boundaries created from the randomization has been marked edges whose seams are marked. So you can just go to face selection mode and press L, and it will select those face islands. And this is very advantageous for face for selection, and also for isolating an area where if you want to model some details manually, you can press Shift H and then Alt H to get them all back, to get them back. So L Shift H, and anything you design here, you add here, will be limited to this selection. So for example, if I subdivide this and Alt H, the rest of the selection will be uh, the rest of the mesh will be unaffected. Or if I add a loop cut here, Alt H, the rest of the mesh will be unaffected compared to them being visible all the time. Okay, so another use is that you can, of course, unwrap this using the mark sharp, using the edges whose seams are marked. There, it's not perfect, but at least um, the that feature will make it easier for you to actually UV the random result. And all you need to do is use something like text tools. I don't have text tools here, but something like text tools to uh, text tools. You can find it. It's free, but you can of course text tools for Blender, and you can use the command right there to actually flatten this and make it square, perfectly square. So it makes it easier for you to UV this using this feature, but mainly I mainly use it for the layering system. Okay. So, but for this instance, we're just going to use another feature, which is the selection. And in the settings, you can see the sharpness here. This is similar to the select linked in edit mode. Select linked flat faces. So it selects all the elements in this instance a face, all the elements that are connected to it, which share the same sharpness, or I guess this is normal angle sharpness, and if it's under this value here, then it gets selected. So for example, if it's a cylinder, and if we use the same command, select link flat faces, F9 to bring up the redo panel, and then increase this, then you also increase the amount of faces being selected until you go past 90 degrees. Then this face here is also selected. And this is the same with, for example, random loop extrude. You can see that the sharpness here is similar to the property used by the link flat faces, and by default it's 15 degrees, which works for most topology, and they are being used by most of the operators here that operates on geometry. So for example, if I press Alt and click, this is called an event hotkey. an event, not event hotkey, an event, um, yeah, a key event. Yeah, this is called a key event in the add-on. So if you press Alt, keep pressing it and click on random panels, for example, then it acts like the select linked in what I've shown you earlier. You see, like the select linked or link flat faces operator, and the sharpness value that it uses is from the settings. The only disadvantage that it has over the vanilla operator, which is the link flat faces, is that you cannot change the sharpness settings in the redo panel because this is the redo panel of the random panels or any of the operators. You can only change it before using the operator using the settings. So that's the only disadvantage there. But somewhere 15 to 30 degrees works for most of the geometry. That and it will stop at edges that have 90-degree sharpness. So something like 15 to 30 degrees already works quite well, and you don't need to change it every time. So in my timeline videos, you can see me pick faces from different face islands, and then since you know that the randomization operates on selected faces only, and if we don't use the alt event um, alt key event, then if we use random panels, it will only operate on the face selection. However, if we press Alt and use random panels or click on random panels, then it will operate on those. Uh, it will expand the selection and operate on multiple faces. So that's how I do it. So in the timeline, you can see me do this. So it's much faster than doing this and then going to select and link flat faces and then going. It actually selected the, oh, it's 85, 15, and then using the random panels operator. You can actually use the most of the random operators in edit mode, but I just like using them in object mode. So Alt and then click because it's easier to see the resulting design or pattern. Okay, let's go back. So this is our first layer. Cursor to world origin. I have I have an OCD, so things like the 3D cursor being everywhere. So I need to just return it to the world origin for some reason. Okay, so instead of using the LHAT key, we're going to avoid this because with the LHAT key, it's going to select these really long and thin faces, and it can actually cause spiking geometry, where the geometry kind of spikes like that. And that is where the event offset property setting to off actually is useful for getting rid of the spiking geometry. But to avoid that, we're not going to use the LHAT key for this, but instead use the Alt key event to select the faces that are connected to these flat faces, so thereby not including these ones here. So we'll pick. So we're going to leave some areas more relaxed than actually filling everything with details. So for example, here and here, here, Alt, and then press Alt and then click on the operator. and we increase the subdivision. These are overlaps. We need to fix some of the properties avoid the overlap, like the thickness. Okay. And then um, so another thing about the merge panel, the or the merge panel toggle in random panels, the subdivision doesn't just it affect the face selection; it affects the entire mesh. So as you can see, if I increase the subdivision, the entire mesh also increases its resolution, not just the face selection. So be careful with that. So right now we're just going to use a single subdivision for the increased amount of faces and probably use lower. So lower panel size means more face groups or panel islands. And we're just going to look for something that works for the design we're trying to, or for the overall concept of the design we're trying to achieve. Don't worry about the, oh, and don't worry about the resolution. So since this is primarily made for concept art, we are going to go into the uh, design first before topology. So it is much easier to repair the topology by just doing the design first instead of modeling then fixing the topology at the same time. Is you're going to waste more time doing that than just focusing on the design first and then going to the topology and then repair it. Okay. And since this is mostly angular, it's really easy to actually lower down its topology. 0.001. Okay. So let's try a bit of triangulation. And you don't have to be increasing the resolution all the time. Once that you've seen that the mesh already have that amount of faces you need for the randomization to play with, then you don't need to be increasing the resolution all the time. Okay, let's pick another spot like this one. Oops, it's too busy. Okay, I think we might need to use the bevel. So let's use the bevel, and it resulted with because of the this is because of the uh densely packed faces in this area right here and the amount of width and offset. So you just have to edit that to get rid of most of the errors. But there we go. But you can also use a command here to avoid smaller faces. In the mesh filter select, this will deselect all the um, thin faces based on these based on the shortest shortest edges that they have. So we're just going to deal with this set of faces right here. And panels, bevel. Bevel is also destructive, purely destructive in random panels. So I suggest you go check the online documentation. Let's increase the, there we go. Let's increase the panel size, max panel size to, so by using number, this means that minimum number, the smallest face number count for a panel island is one face, and the maximum will be 149. And the randomization for the panel size will happen between 1 and 149. So for example, if I use 10, then there will be a limit of 10 faces per panel islands and a maximum of 149 in this case, or 150. And then you can randomize the result using the panel seed. So for the larger areas here, we can just use the bevel. We can avoid splitting the borders, which in this case is a bad idea. Okay, it's right here. So I'm pressing the Alt key event. This is really helpful for flat faces and also curved faces, which meets the sharpness angle threshold. So the, okay, there's a lot of bent faces there. There we go. Can avoid, okay, can avoid splitting the boundary. Let's try it. There you go. And the great thing about this is that you can bake this. To create a bunch of this and just bake the details on, use the texture maps for your future projects. So after the randomization, you can have a choice of actually modeling in some manually modeling in details. Control T, Alt J, Control T, Alt J, F9 hotkey, increase this to 180 degrees. There you go. So with the topology, you can just press X, limited solve, and then triangulate. There you go. If you don't want to bake this and just use the geometry, you can use that method. Limited dissolve, Control T. For some topology, there might be shading errors. You can just go in and repair the topology. And the shading errors are mostly caused by overlapping vertices and faces. So you can just repair that manually. And you can build a library of this and then save it and then use the asset browser to basically drag and drop it to your scene using the again the asset browser. But we're going to keep, in this case, we're just going to keep the quad topology. You can use dribble bake, the dribble bake add-on to bake this detail with ease. So I suggest you also read the online documentation for this add-on, and it's really powerful. It's not that popular as Random Flow, but I assure you it's really good. Good sharp. So you can start modeling in some manually model in some of your s- some details instead of them being purely randomized. Control T, Alt J. Alt J gets rid of the triangulation. Okay, I think we need a bit more. Again, don't worry about the topology. Control P, Alt J. Actually, you don't need to. We we just need the quad topology in this case for easily modeling easily model manually model some details in, because the quad topology really helps for the selection and creating shapes much better than if you're actually using inguns. If you have tools like the creative flow and draw cuts, then creating details on inguns is much easier. But if you don't have this tool, then the quad topology is helpful for you. So maintain the quad topology as long as you have plans to to manually model in some details. And for hard surface, that's going to be just background assets like door opening, closing, or crates or sci-fi panels just being static. It's not really important for them to be quads. You can just turn them into ingots, and that's and triangulate, and then they're going to be okay. They're not going to smile, walk, bend, or twerk. So it's okay for them to be um, ingons because they're not going to be animated. Okay. So I think we're kind of finished with this, and let's go to. I mean, I could add more, but let's just continue with the shading. Shading. So random flow again. Look at the online documentation and look for the append materials operator. This will append in some basic materials in the Blender that you can use for the your randomized meshes. These are not completely complicated materials. This is just there for you to get started and uh, for you to easily shade your models and also learn about the Blender's material system by taking a peek at the shader nodes that I made um, for them. So up in materials and creative flow, go to materials and assign material to this mesh. And these are the materials that are included in the append materials operator for cloth, R flow cloth, cylinder, metal, hard object. This means that object mapping, UV mapping, object mapping, UV mapping. So we're going to use just this without the texture. Okay, so we're going to actually edit this first. So let's go into shading and look at the result of the quick dirt. You need to have node wrangler activated in order to use this feature. And so basically control shift click on a node and it will show you the preview on the view part. Then to get back on the original output of the shader, just click on use the control shift click on the hotkey on the main shader and then go back to the original result. So cavity mask, we're going to edit this. Edge mask, also this one. So 0.005 and set the strength to 1. Scratches, probably way too big, so let's use 15. Quick dirt, something like 2. And this is looking radial, so we're going to increase the offset to make it more diffused. There we go. And you can also use the offset um, to randomize the position of the dirt effect. There we go. And then we're going to add lights. Just pick one. We're going to use, actually, you can use the alt key event for this. Instead of using you can also use the select the link flood faces, but you can also use the alt key event in the random flow add-on. Alt and then click on an operator and then don't touch anything to get the same effect as the link flood faces. Then you can use creative flow and then vertex color material. But since we're not using the vertex color, toggle this off and then rename the material as emit and then press OK. And here we're going to change the principal BSDF to emission. This added the material to the face selection. And set the strength to something like 20. Change the color. Something like that. And for the base color of the geometry, we're going to use random vertex color. I'm going to use the preset no saturation value 3, which means that it's going to use gradation of black and white for and there will be no saturated colors, and there will be hard gradient for the value, which means that it's kind of like using a color ramp which in this case has 3 color steps, which is separated evenly, and we're going to use the limit sharp. Since this is only one object, we're going to use this to create different colors for the details. And since there's no separate panel islands because the randomized face groups are merged into the source mesh, we're going to use the sharp limit instead, which create different vertex color based on the sharpness of the edges. And if there's no mark sharp edges on the mesh, we can use the mark sharp toggle here. But since it already exists on the mesh, we can just use the existing mark sharp edges. Then selecting the face that uses the other material, in this case the airflow material, we can go to, when using Node Wrangler, we can go to input and this attributes menu will show up and use the vertex color. The vertex color attribute is made using the random vertex color operator. So unplug the color here. You can intensify or change its effect using the color ramp. You can, of course, take advantage of the color step or the higher gradient value by using constant and assigning different colors to this color step based on the number of color steps that we used for the random vertex color operator. In this case, we used only two, so we can only use two colors for this particular geometry or particular vertex color. So something like that. So this is monochrome M for mute monochrome, and this is colored. Okay, let's try the colored. I don't use, if you see my videos, I don't use colored too much, colored versus color too much, or saturated versus color too much because the it's too much work trying to make them look convincing. So I just use gradations of black and white mostly for that effect. But let's try colored vertex color, saturated vertex color this time. And I'm going to also affect the scratches. Points that is actually too strong. 0.05, 0.05, 0.1, 0.2, okay, zero point 0.1. Okay, and we can also use the light UV right here. But this works with UV, but we can UV this um, using just cube projection. You can use unwrap because of the marks of the edges that have marked that has this their seams marked. But in this case, since this is mostly angular, I can just use cube projection and then increase the strength and play around with the values on this one. So let's make the lights bigger by decreasing the scale. So this is the inner scale, and the cubes that you see here are the outer scale. So the separation is marked or is being implemented using the outer scale, and the inner scale means the scale of the squares inside those bigger squares. That makes sense. And factor is, of course, the factor is that the influence or the strength. And you can randomize their positions using the offset property for the inner and also for the outer scales. Okay, so something like 150. If you don't want to use the shader, you can also use something like normal. There we go. And use something like random cells and use the image size 3 or image size 5 preset. Increase the resolution to make to make the face smaller, and you can see there's generating these kinds of effect. And the island size means that there's going to be 3 lights in maximum that can be generated for a particular island. So let's just try 25, and you can um, randomize a particular island using the proxy, or randomize their overall location using the pole seed right here. So I think this looks much better. So we're going to use this instead of the shader. The good thing about this is that you can affect this position much easier than using the shader, because this is the generated uh, this effect is using geometry. Okay, so for example, let's go back to one. So for example, this one. Okay, so let's just pick this geometry. So go into edit mode, and for example, you don't like this. You don't like the slides here. You can just use circle select, select them, then XF, select, remove those faces. Some of these faces are actually buried. There we go. So you can use it like that, or even select a face and then change its position, or duplicate it. So that's the advantage of using geometry. And it's also, because of the parenting system, it's parented to this mesh right here. Okay. And I think you can also join it, and then you can also join it using Control J, and then it will still be using its own shader. There you go. Okay, so we now have this. What more can we? So if you don't like the vertex color, you can change it anytime. Okay, so if you want to turn this into an asset, just mark it as an asset, and then you can use the asset browser to drag and drop it to your feature scenes. But you can join this and limit the solve, Control T. Then you have a geometry based model that you can use for your scene, and then you can I think use then you can use the array modifier for this. Add modifier, generate array, and -1 in the y-axis. There we go. Raise the resolution, Shift D, and then let's do it on the x-axis. Set the y-axis to 0. Then you can use this as for the panels. There's shading error, but you can repair that yourself. And another thing is that you can also uh, bake this geometry using dribble bake. So I'm going to set a few property first using the lowest geometry, meaning that the zero depth will be based on the lowest geometry of the model, and then bake to last images, conform to shape, conform to selection, scale to bounds. I've not used this add-on for a while because I've been writing the I may have forgotten some of the tags. I've been writing the online documentation for random flow. It's taken me weeks. Last baked images, normal. Okay. And the name, it has a name by default, so that's okay. And we can use we can bake the AO displacement, normal AO displacement. Leave this untouched, leave this untouched. And AO sample is 16. Let's just try it to make it faster. Margin for bake origin is going to be the plane and bake to. We don't have an external or auxiliary bake to object, so we're just going to leave this blank and cross my fingers, hope it works. Go to image editor. There we go. And bake. There we go. This is the displacement. This is the AO, and this is the normal. And why is it why is the normal so noisy? But that's I don't know if this is a 4.2 problem or I don't know. A lot of bugs have been introduced in 4.2, but the normal is not supposed to be noisy. Okay, so that's how you can do it. You can either use geometry, making it light using limited dissolve or decimation. Oh, not decimation, just limited dissolve. Decimation will destroy most of the details, so just use limited dissolve. It will conserve the details using the angle threshold. And also you can bake it using dribble bake. This is the displacement. And let's try it. But I have no idea what's happening with the normal. Why is it noisy? Wait. 2024, 2048. Bake to last, conform shape, conform to selection, scale to bounds. I might have to reread my own online documentation for this. Oh my god. Size AO 16. How about 16 for others too? And bake, it will bake on the same map, so bake. Okay, bake displacement, bake normal. There is still some noise on the normal. Why is that? Might have to research that later on. But okay, let's use that. Let's create a plane and make it somewhat the same size of this detailed geometry. And then let me see. Let's unwrap it with the same um, format as this one or layout. So unwrap. Let's go to UV editor and let's line up bake AO and rotate this. And then how can we align this in the center? Okay, so now I'm going to create a new material for this. And oops, I'm gonna actually use the displacement as a color and affect it with a colorant, just like we did with the vertex color. So this is just temporary, and we're going to use normal, non-color. Okay, displacement and normal should be non-color in the color space, and set it to the normal, and go to vector and set this to and use normal map. There we go. And it has that grainy. Oh, I know where the noise is coming from. That is from uh the bump from the original shader. Look, we're using bumps coming from this shader nodes, but because the map is too too small to incorporate all the details from that bump from the original object, it's coming up as noise. But at least with we have discovered the source. So what you can do instead is, if you're just going to use this as background assets, you can just disable the bump by disconnecting them, or using or setting them to 0 before baking. For the lights, for the baking of the lights, that's because they are different geometry. That will be for another video. Let's just focus on geometry in this case. Okay, and material. Then the AO, you don't have to include the AO if you don't want. It's just a additional flavor for the base color. You can mix it and multiply it and color vector right here should be RGB, and if you increase the, is it even adding up? I guess it is. And then um, for the displacement, if you want to use displacement, you have to use subdivision. The quality of the displacement will be equal to the amount of resolution that you will have. You will only have to use displacement if you want to if this is closer to the hero or the subject. If this is closer and you want this to be uh, displaying geometrical detail instead of just being just flat representation of the detail using normal maps, then you have to use displacement. First, we have to add a subdivision modifier. We don't need the Catmull Clark. We don't need the softening of the edges. We just need, or the curving of the edges. We just need simple geometry. Go to viewport, disable this so we can see the subdivision. Increase this. And if you want to render this, the levels viewport and the renders the levels in the render should also match. Just remember that. So for this detail, we need to actually have to maybe go to 7 or 8. But remember that this will have using displacement in the viewport and in the render will give a really uh, big processing overhead. So just be careful of that. If you're using Potato PC, you might have some fries at the end. Okay. Vector, go to displacement and click this on displace. Connect that on the displacement input, and with our displacement texture connected to the height, and you can see it rise up. We can actually sit on the height or the scale. Oh, it's the height. Oh, wait. Go to material, displacement, in the settings, change this to displacement only. There we go. And mid-level is 0, and scale is something like 1, or let's match the original geometry. We can just lower it down or increase it. And you can see that we don't have enough resolution for the displacement to actually displace the texture map accurately. So we need more faces for that. So let's increase the resolution. There we go. Somewhere around 9. And this is the amount of faces that you have currently. So if you're beginning with 3D and you want this rendered on your next to your hero subject or main subject, and you want more detail fidelity on this object, then you can use displacement. But for objects that are farther down or far away, then you can dispose of the displacement and actually just use oops, okay, create another material and disable the displacement. So for far away objects, so for example, this two is near the hero or the main subject, and this is farther away, so we don't need displacement for that. Okay. So this is how to make your scene lighter. So again, for the panels that are near the hero or the main subject, you can use displacement to create more fidelity on the details. Then farther along the chain, and for objects that are farther away from the camera, you can use just bump. Okay, so that's the difference between displacement and normal and how you can use them to optimize your scene. And there are many, of course, ways to use that, not just not just that. Of course, displacement is going to be good for movies, but for games, they're usually just using bumps, normals, things like that. Okay. So I guess this is it for now. And yeah, you can model a lot of this, and then if you want to use to create your own library to use for the asset browser, and then if you want to use just the geometry, not textures, you can just and make the slider. You just limit the solve and triangulate, manually fix the shading error that you encounter, and yeah. Or you can bake it using the Gribble Bake, like I've shown you, and also create a library of this. So, and this is lighter than using geometry, of course. And you can save those images, and you can create a library of geometry or a library of textures. because you can use this as sci-fi panels on walls, on floors, or in ceilings, or you can use this as paneling for spaceships. And when you have enough library of this, say maybe 50 or 100, then you can just drag and grab those to your scene. The advantage of that being the advantage of that is your patterns or your designs are going to be unique compared to the ones that are being bought that are already pre-made from stores, because other artists may have it, and you might, oh, I've seen that asset pack before, so it could be an advantage or not depending on you, but you will have your own unique library when you use this add. So that's my pitch for that. So this is how you uh, use random flow to create the sci-fi panels. And I hope video has been informative and it's not that complicated. And I hope it's been helpful to you, even if you're just starting Blender or 3D modeling or that fact. So I'll be doing more videos like this, and being an adept user of my own add-on, of course, and Blender, my some of my movements may be too complicated. So just ask questions in the comment section. Okay, so don't be ashamed and just tag the time that you want me to explain, and then I'll, if possible, if I see your comment, then I'll answer them. Or you can join the Discord community in uh, the link is in the README file in the docs section of the add-ons. Okay, so this is it for this video. I thank you for watching. If you have any question, use the comment section below or the links in the description. And again, thank you for watching, and you have a nice day.